Welcome to the new Cyber Frontier, bringing you the latest news on the local Colorado economy and initiatives that focus on the development of cybersecurity economics. You don't have to be a computer or cybersecurity expert to get plugged in. Your host, Chris Gorog, brings it straightforward, asks the tough questions, and brings the cyber world to a level of understanding for everyone. Chris is personable and opens up with our guests on issues we all would like to see addressed. You can find us on the web at www.newcyberfrontier.com. Now join our host as he introduces the topic for today's New Cyber Frontier.
Welcome to today's episode of New Cyber Frontier. Today we have Chris Murphy, who is the CEO of Cyber Safety Harbor. Now they have a process and a technology called Secure Access Technology that we're going to talk about, and hopefully we can get across. We've got a little probably more technical this time than most, but bear with us. Chris, welcome today. How are you?
Just great.
Yeah? And down in beautiful Clearwater, Florida. I'm so jealous. Except for you said the beach is eroding away, so.
But it's still sunny and beautiful.
Lived there for quite a few years. I really enjoyed it. But today, let's talk briefly about your technology and what you do. First of all, give us your background personal. What is your background? Where do you come from?
I was born in Connecticut. Started programming in the early 80s. God, I started programming with a language called CPM, which happens to be my initials, by the way, which turned out to be a curse a few years later. Moved on through pretty much every language that's come along.
CPM.
Fortran, PL1, evolved through to forming my own consulting firm. And in the mid-90s, I started getting a lot of phone calls from people who were using CPM because I was CPM software under my initials. And it was kind of funny that, you know, here it was 18 years later and that stuff was dead and people were still trying to keep it running. 10 years ago, I came up with a concept for cybersecurity and it has pretty much taken over my life.
I know that feeling. Well, we're going to talk now about what it is that your technology is and does.
Okay. Well, I'm the founder of Secure Access Technology.
Okay.
It's a multi-dimensional approach to the internet.
Okay.
And we are bringing it to market over the next few quarters. And we're doing product education at this point in time, explaining why everybody keeps failing when it comes to cybersecurity.
Interesting. So Secure Access Technology is your company?
No, Cyber Safety Harbor is my company.
Okay. Secure Access Technology is what your product?
Is what our product is. Well, that's not true either. Our product is called a Cyber ID.
Cyber ID.
Yes. It's based on Secure Access Technology.
So Secure Access, are we talking application security into data centers? Where do you focus?
We're talking about secure access.
So
the mistake of the internet was that no one ever thought about the issue of secure access. And every solution that has been deployed since the internet's been commercialized has dealt with the problem after the point of secure access. So they fail because they don't address the major problem. It's called having a secure portal in a public environment.
But who would be your end customers and who are the users?
Our end customers are anybody who stores secure data and provides access using a web portal.
So cloud? Are you at the cloud?
Anything, everything.
Everything.
If you have a logon screen that loads from a browser that accesses secure data, you have a failed security model.
So we're talking web access? Or are we talking access like sign on to your Windows? Are we talking people who...
We're talking the ability to access data stored somewhere other than on your local computer.
Okay.
Your bank would want to deploy this. Your insurance company would want to deploy this. Your credit card companies could have prevented every fraudulent online charge since 2008 if they had deployed this technology.
We'll be right back with the rest of today's show right after these brief messages from our sponsors. Cyber Resilience Institute helps build strong cyber communities designed to prevent members from attack. Like building a neighborhood watch, it takes coordination and a sharing community to protect our identities and valuables in the virtual world. Typically, we hear that organizations know they need to do something to protect their cyber assets, but don't know where to begin. Let Cyber Resilience Institute help your community create an action plan. Cyber Resilience Institute will build your community or business marketplace so that it is designed to support a collective cyber defense. Contact them for more information at cyberresilienceinstitute.org.
So tell me how you are marketing and placing it to people.
We are currently introducing it through a grant program.
Okay.
We're seeking 500 entrepreneurial spirited people to be assigned exclusive districts around the United States with an exclusive customer base, and we're going to pay them obscene money to take care of our customers.
Okay, so are you funded to do this?
We're currently funding it through hard work.
Okay.
Best funding in the world.
Best funding in the world. So can you explain anything about the implementation to me that I could grasp, I guess, start at a high level?
Okay. When the internet was created, we all shared information.
Okay.
Then we decided that we could market, and we put up websites for marketing.
Mm-hmm.
Then we put retail in a public environment. That makes sense. Retail is public. Retail went to the internet.
Okay.
Then we put secure data in the internet. And we accessed it through a public portal that was meant for the free and open exchange of data, then was converted to marketing, then retail, and then security, but it's still the exact same open, accessible, public environment. Secure and public are an oxymoron, period, and they can't be allowed to continue.
Okay.
With the multidimensional approach, the internet is not the browser, and it is a browser dimension that we have all been trained to think of the internet as. I'm old enough to remember when we get on the internet with a terminal window and typed code.
Uh-huh.
Okay? We have all been led to believe that the internet and the browser dimension are the same thing, and the only way to use the internet is through public access.
Okay.
The truth of the matter is, the internet is nothing more than a pile of wires and cables and assorted switches and routers and termination points.
Mm-hmm.
And the browser is a tool that we use to navigate that. There are other ways to navigate it that allow for you to create totally independent environments, all existing in the exact same place at the exact same time, using the exact same equipment. Completely independent.
Is this software running on a machine at two ends that you then connect between?
The software doesn't run anywhere except for when it's needed. It doesn't exist except for when it's in use. It's not available through a web browser. It's not available from a website. It's not installed on any computer. It doesn't load from any website. It just creates itself, exists as long as you're using it, and when it's done, it disappears, leaving no evidence it existed in the first place.
Sounds like a virus.
Think about when you go to your bank.
Okay.
You go to your bank's website, and there is a username and password there.
Uh-huh.
Okay? Here's the simplest way to understand this. Does your bank know who their customers are?
They do not.
They don't?
Not virtually.
But the bank knows who their customers are. They don't know when they go to a website because they use a website.
Okay.
But a bank knows who all their customers are. They have a defined user group that they know that came into their bank and opened an account or opened it online, but they have an opened account there.
Okay.
So they know who their customers are.
Okay.
Okay, with the exception of companies like JP Morgan or Citibank,
Uh-huh.
the average bank has several million customers. We're talking regional banks, not these massive multinationals.
Mm-hmm.
let's say you banked at a local regional Colorado bank that had a total of 1 million customers.
Okay.
Okay. That web portal on their website is available to 6.4 billion devices.
Mm-hmm.
Okay. How do you secure 6.4 billion devices from getting in? Poorly at best.
I would agree with that one.
Okay. If the bank knows that there are only 1 million customers, why are they putting a portal out there where 6.4 billion people can get to it? There's
Okay.
no reason for that. They know who their customers are. Their customers are the only people who should see that portal. We create the ability to make a internet-based private internet dimension for that bank where only their customers can even get granted access to a web portal.
Okay.
The portal comes into existence when it's needed, evaporates from existence when it's not in use. It leaves no footprint. It uses no installed software, and it has no browser-based connectivity related to it.
So
Yet it's over the internet.
interesting. So this is kind of almost whitelisting. You have to know who your customers are. How do you define who that customer is? What point of data? Use an IP address?
Depends. Our product is we distribute a cyber ID. Think of it like a driver's license to the internet.
Mm-hmm.
Okay. You use your cyber ID to connect to an authentication server.
Okay.
All you do is plug it in. It does everything by itself. You plug it in, you click start, it goes out to an authentication server.
What do you plug it into?
Any USB port, micro USB port.
So it's a hardware device you're sending to a customer.
Must be hardware device. There's no other option.
Okay.
And believe me, I've looked at all the options. There are no other options. You can't use optical scans because they don't work.
So
You can't use fingerprints because they don't work. You can't use facial recognition because Facebook destroyed any use of facial recognition.
Yeah. So what's the storage on the thumb drive? Do you use a particular product for that on the USB?
It's a proprietary product.
Okay.
It's read-only. There is nothing that can ever be written to it. All it contains is a unique serial number that only that token will ever have. It's manufactured into the chip, so you can't flash it to change it. It's completely encrypted, and it maintains the ability to create its own environment that exists in RAM only for as long as it's in use. The minute that token is unplugged, RAM is flushed, the memory is released, and everything is gone. No evidence it ever existed.
Okay.
It caches to a virtual drive that is part of the token that has 8 gig of memory on it, so that anything that needs to be cached is cached in a virtual drive on the token. So when you unplug the token, the virtual drive and the virtual memory go away completely, and all evidence of the existence of the session are gone. If you don't know you were there. Now, if you think about the failing of cybersecurity today, especially let's pick the government space because I'm having so much fun kicking them right now. The government uses PKI encryption.
Mm-hmm.
Okay. PKI encryption requires you to have a 250 megabyte certificate on your machine.
Yeah.
I won't even talk about the number of years ago the Chinese learned that if you put bots on machines that identify that certificate, when the certificate's in use, you can use it to pirate it into the government and hack it. And thus the government gets hacked on average 50 to 70,000 times a month successfully.
Okay.
Permanently attached cyber certificates can be compromised. Browsers, by definition, spy. So the fact that you do anything secure in an environment that you know is spying and reporting to its manufacturer is a security protocol violation in itself. I had an intern who used Chrome to go to Expedia to book a fraternity convention in Vegas. Don't ask. Bunch of college kids in Vegas. Would have been an interesting party anyway. After he was done executing the purchase on an HTTPS connection on Expedia in Chrome, he went to Google Map and there was a pin in the map saying that he would be in that hotel on that date. If he was working in a secure environment making a secure purchase, how did Google know to put a pin in the map and tell him where he would be staying on the dates that he would be there? What makes you think they're not spying when you're doing your banking or anything else?
We'll be right back with the rest of today's show right after these brief messages from our sponsors. Over 3 million data breaches happen every single day. That's over 2,000 records being compromised every minute. So often, we focus on securing web data access. But what if the attackers are already inside, having gained direct access to your storage through data management software? When it comes to communications that go directly into your storage devices, make SNIA your first line of protection. SNIA's conformance testing limits outdated communications that are known to be used by attackers. It works continuously behind the background to make sure your storage is protected. To find out if your data is truly secure, visit our website at www.snia.org/cybertest.
So a question for you about, I'm kind of going back to this device you plug in because I've worked a little bit with them. How are you preventing a replay attack from somebody that would plug into a USB and monitor the USB? You said you're encrypting between the computer and the device and the thumb drive?
The drive doesn't use anything related to the computer except communication links, monitors, keyboards, mouse. No one can avoid that. If there was a way to avoid that, we wouldn't even use those things.
So plugging in, if somebody plugged into the device and watched the USB bus, a replay attack is something that could be done?
No, because all of the encryption is handled from the device.
How do you, what kind of encryption do you use? Is it an AES encryption? Is it asymmetric encryption? Is it symmetric? How do you do it?
We do two separate encryptions.
Okay.
I won't get into a lot of detail, but the encryption related to the first level of security is device specific. Every device has its own unique encryption model.
Okay. But in order to communicate with a device,
challenge and response process, so that when the connection is made, we send a code down to the token. The token encrypts the response that was at the challenge, sends it back, we unencrypt the challenge, and if it's correct, we then send a path to where the token belongs. A token doesn't even know who its owner is. It just knows that it's where its authentication server is.
well, let's go back to this handshake between a token and a computer. You're sending information to encrypt the communication across the USB, but you said that there's nothing on the computer. How would you be able to have shared encryption keys if there's nothing on the computer, and then those keys are stored somewhere on the computer?
They're stored on the token. The token connects to the authentication server. The token, first of all, you plug in the token, you click start. It creates its own unique private environment that exists in RAM. Period.
Directly to the website, or to, I'm talking about between the computer and the token. How are you protecting that bus?
It's an encrypted environment that's being created. The communication link from the token to the environment is encrypted. The only time that you're...
What I'm saying is I've worked on these, and in order to encrypt between the computer and the token, you have to have a key on the computer that then is in software somewhere and it's accessible. How did you solve that problem?
It's stored in the virtual environment.
But it's on the computer in RAM.
RAM.
And where does that come from? The website? It comes from the website?
It comes from the authentication server.
So you asked for a key to communicate with the device across the internet, and then that key is stored in volatile memory, and that volatile memory could never be exploited?
We lock the memory.
We
segment a part of memory away securely. We encrypt that security.
Now this is memory on the computer.
Well, we're using memory that's actually not part of. It appears that it's on the computer, but it's not. We're using volatile memory that we have on our token, and we're provisioning it so the computer thinks it's part of its inherent memory.
But if that key exchange happens all the way to the token, that key is visible across and through your computer at some point. Across the bus, the USB bus. So we're talking replay attack capability.
The encryption key is never passed. Everything is done through a challenge and response through the first level. You're going farther down the road than I am at it right now. That's, I think, part of the problem here.
Okay. The reason I'm doing this is because I've worked with companies trying to solve this problem a couple of years ago, and it wasn't solved. And I'm curious how you solved it.
And at one of the levels, if you're going to drill down that much, I have to bring in some of my C++ programmers and other people that, as the CEO of the company, the inventor of the technology, the last 3 or 4 years, I haven't been in the lab. I wish it was, but I've been running a company.
Understand.
Okay.
Okay. So we will go a different direction then. Okay. So I understand what you...
Far down there is I can give you coherent answers, but I can't be sure I'm going to give you the correct answer.
Yeah.
And I'd rather give you the correct answer than a coherent answer.
The last time I was in that industry, granted it's a couple years ago, that was a design limitation, meaning something that nobody had been able to solve in the whole industry.
We solved it.
Well, that's an interesting fact that we will for now, we'll take your word for it, and that's something you can show to your customers when they hear this, that you've solved this and you have a solution for it. So I think that would be the trick. That's what I know was missing in the past.
But no, that's not what's missing. What's missing is the fact that if you provide public access, you've already violated any level of security. We eliminate public access.
Yeah, I guess I'm talking about on the hardware level, communication with a device that was a security device outside of the computer. There was always a problem with the bus. So granted, you're solving industry-wide a problem from the bank to your computer. That's a great solution.
Okay. Off the record, we've got attack research.
We're still recording, so we're on the record.
Okay, then I won't tell you the verifications that I could provide you as to who's been looking at it, because that would go too far. We're very careful about the proprietariness of some of the things that we've done.
Okay.
That's a nice way of putting it.
And everybody should be in the security world. We have to understand that you've solved the problem, how you've solved it, but the way you getting into your roots, that's your secret sauce.
Okay. Now, what we do is we provide a token that is, except for a unique serial number, identical for absolutely everyone in the world.
Okay.
The only way you can identify where a token belongs is if someone puts labeling on it.
Okay.
All a token knows is an IP address of an authentication server. And that's not quite true. It's much more complicated than that. But again, we're not going to get into that level of detail. It goes out to an authentication server, makes the connection, handshake is made, encryption begins, challenge and response is done. If a token has been reported lost or stolen, it self-destructs at this point. Before it even knows where it belongs, it will self-destruct.
Does it have a battery in it that keeps the key or the unique identity in volatile memory?
It's no, the serial number of the token is built into an encrypted chip produced by Atmel, and there are some chip technology with fuses in it that if you send the right code, it burns it out. Gotcha. So if we get a report lost or stolen, we destroy the token so it can never be used as anything. It's read-only, so it's not even a flash drive. So if we shut it down, it's dead.
Yes, Atmel has some good technology. I've actually been familiar with them.
Very, very good company for using security chips. So our security on the token is chip-based. So you can't flash the chip, you can't duplicate the chip. We're very specific about architecture so we can make sure that it is a validated token. The token goes to the authentication server. Let's just say that your bank issued it. As soon as we found out that it wasn't reported lost or stolen, we would send the path to the bank back to the token. The token would then connect to a proxy server related to the bank. The bank's proxy server would then check our authentication server to see if that token has been activated, authenticated, and what its session ID is. It'll then validate the session ID of the token coming in. If it is, it'll triangulate the communication, start monitoring for man in the middle. It'll load a logon screen, and at that point, our technology becomes the world's most secure container, and you load whatever your functionality is into it. We're backwards compatible to browser-based code, so you can use with minor modifications, HTML, HTML5, .NET, and the rest of that. It's all fully compatible because of our backwards compatibility.
So what if somebody, just a quick question, what if somebody had a rootkit on that machine and they patched into the middle of this process? No way to protect against that, right?
Anything that interferes with the communication link will get picked up. We've had it attacked by multiple companies out of Palo Alto, and nobody's been able to breach it. And the kind of questions you're asking would require us to disclose.
More than you want to.
Yeah.
I understand.
It's a sensitive process.
Understand. So let's go to a little bit higher level. We just dove down in the weeds. And I apologize for anybody listening that got lost, because this is something that we're both in this industry. And we could talk at a level that's probably a lot more deeper than this. But we want to know, this is, what it's going to do, who you're approaching, when do you go to market? Kind of give us some direction, business ideas, and who you've approached, or you probably don't want to talk about customers, but what industries you've approached maybe.
In the previous 10 years since the patent was originally filed and the technology was created, it's been deployed in DoD. I can't say where. Mm-hmm. It's been piloted with Homeland Security in the New Jersey Fusion Center in conjunction with the New Jersey State Police. That pilot was reviewed by the Police Institute at Rutgers University, and all of the participants recommended purchase. Unfortunately, we were trying to sell to the government in an environment where there's less and less government spending. Cybersecurity, you would think, would be a priority, but it's not. So it was a waste. It's being taught at the Cyber Warfare Center in Monterey as the next generation of cybersecurity. I get emails after each graduation class wishing to purchase the technology, but government regulations lock out small companies. I've met with a major credit card company that chose not to deploy our technology, and I will give you the quote, because if they recovered that much fraud, it would call into question their billing structure. So rather than call into question their billing structure, the fees that they charge, they allowed fraud to continue. I've met with insurance companies who've all had a desire to do business, but only with a channel partner. And I'm not adverse to being a channel partner with some corporation, except that every one of them's idea of a channel partner is they take 51%. We can fix their problem. We don't have to sell them our company. Because of the incestuous nature of the business economy right now, the venture economy, if they don't own you, you don't do business with them. So we've locked out. So our product now is going to market in the only place that makes sense. We're selling to law firms.
Interesting.
9 out of 10 have been breached. None of them have any reason to conduct any level of their business in a public environment. We provide an absolutely closed private environment that exists over the internet that is device agnostic. I can plug my token into any computer anywhere in the world and create a completely secure communication link, do whatever I need to do, unplug, and everything that was involved in what I was doing evaporated. Nothing was ever cached to the computer, so any forensics will find nothing, and I can move on. So there's no reason for lawyers to do any business. And when you look at that, lawyers, accountant, wealth management, that's really our target audience. But lawyers are the best. Yeah. Because once you deploy de facto best practices, failure to meet best practices becomes negligent. And when the lawyers are the people who deploy de facto best practices, every 9 minutes there's a breach, and every 9 minutes someone's going to have to be looking at a negligent breach rather than a breach because we couldn't fix it because we did best practices. And that's how you defeat the venture economy that says we must own you to use you.
So a quick question, something I just thought on. How do you, if somebody gets a hold of your token, is there a passcode or something on top of it that you have to be you as well as have the token?
When it connects, let's use your bank again as the model.
Okay.
When you connect to your bank, the only thing that we've accomplished is validated that you have a valid token that hasn't been reported lost or stolen, and that the session is live, it is being monitored, it is encrypted, and we've loaded the bank's logon screen in. At that point, we have no further involvement. The bank should use a PIN or a username and password, and in conjunction with the serial number of the token, use that for its validation to let you into the bank. So if you put a PIN on it, I would have my token and my PIN, just like your debit card. My token, my PIN.
So it's almost like a roving ATM account module where you have your token and your card and your PIN.
And you can plug it into any computer anywhere in the world and connect to the environment securely. Do whatever you need to do, pull it out, and there's no evidence you were there.
Interesting. So definitely an interesting app, one that I'm familiar with as of a couple years ago that was in process. And I would like, I guess, first of all, ask tell our listeners how they can get a hold of you. If you're an attorney and you want to talk about this service, tell us about how to contact you.
Go to cybersafetyharbor.com.
Okay.
The contact information is there. There's a contact sheet. Website has the phone number on it as well.
Okay. Chris, thanks for being on today. It was definitely interesting. Sorry we got so much in detail, but I think that's what's needed to get some of these cyber solutions out. We need to know what they're doing and where they fit in the whole ecosystem and what customers and clients can use them and who should be looking for them. But thanks for joining today, Chris.
Thank you for having me.
And have a great day.
Okay, thanks. Bye-bye.
We hope you have enjoyed this episode of New Cyber Frontier. Remember to get involved. Often we think that someone else will handle privacy and security in the virtual world, but you are the only one truly in command of your virtual fate. Join our mailing list so we can keep you informed of breaking news and new releases. If you have an idea, if you have a question that you would like to hear answered, or if you want to get involved with our efforts, reach out to us at newcyberfrontier.com. We also encourage you to visit our sponsors' links, as they are the ones that really make this show possible. I want to thank each of you for supporting the show, and we look forward to seeing you back for the next episode of New Cyber Frontier.